Welcome back, everyone. I'm delighted to be joined by Miguel Ribeiro Ferreira, who's Director and Senior Management for EDP, Energias de Portugal. Miguel, I'm really honoured to have you here, actually, because of what you're
Hello,
doing
Adam. Nice
and the
to
work
nice to see you again. Nice to see
you're
you
doing
again.
at EDP. No, it's nice to chat with you again. So
It's
we're
a
going to go
pleasure,
through
Adam.
just a few questions because
Yeah, sure.
I'd like to get your views personally.
Mhm.
Sorry, welcome to the event first of all, Miguel.
It's a pleasure, Adam. It's a great
Uh,
pleasure.
so we talked a lot already this morning about different areas of energy transition. So a lot of it's based around hydrogen and what sort of organisations are doing behind that, but also other areas to decarbonise. So, in your opinion, Miguel, what opportunities and challenges do you think network operators face in this sort of road to energy storage technologies, and especially the role they play in the energy transition for the future?
That's a great question, and it's a very interesting issue. Well, Adam, as you know, renewable energy is an awesome and critical technology for these long-term objectives, but it operates and generates based on the rhythm of nature, which does not
Mm,
always meet our needs in the right moments in the energy demand. For instance, at night there's no sun, but still we need electricity. Nevertheless, it will surely be possible in the near future to address these needs using storage to transfer energy from a moment in it is generated to the moment it will be needed. I've taken some notes so that I don't forget everything in this very
mm.
short time.
I do the same. Don't worry, Miguel.
But again, I mean, storage will have to be operated in different energy consumptions horizons, namely intraday, daily, weekly, seasonally, interannually, and hopefully one day annually. Countries like Portugal and Spain, with large hydro resources, already rely on pumping storage to meet our part of storage needs. Presently, a lot of more storage is needed, and to stop that restriction, utilities are now starting to bet on batteries and other alternative storage technologies, such as chemical, mechanical, and again, as well as hydrogen. Nowadays, the
Mm,
most common battery technologies, such as lithium, can only store several hours of energy, but it is increasing, and it should be kept in mind that these technologies nevertheless, they are still very expensive, although it is expected that such prices will reduce in the future with innovation and eventually new alternative technologies such as iron-based, salt-based batteries and others. So batteries and storage are a key issue in this energy transition and in networks. For
mm,
instance, batteries are already appropriate to provide several grid services such as frequency regulation, primary and secondary regulation services. Batteries, in addition to storage energy, can also provide instantaneous power and system services that are critical for the grid operator. Just to give you an
mm.
example, the introduction of batteries at critical points in distribution network can avoid new investments in transmission capacity, or at least postpone them for those investments, enabling to network operators to prioritize other network investments. On my point of view, involves correct regulation that allows markets agents who can sell and buy energy at the same time to provide additional
Mm.
system services, like having, for instance, uh, end-to-end customers storing and injecting energy in the smart grids with their decentralized solar panels or other renewable energy solutions in their premises. These solutions, together with storage, may significantly enable the energy transition. In other words,
Mm.
even though it is a bit technical, systems with a lot of renewables lack inertia. And to solve this issue, batteries will have to have inverters with grid forming capabilities, which we're already starting to see today. Another area which is worth looking at is V2G. V2G is
Mm.
vehicles to generation. Electric vehicles, as you know, basically are batteries on wheels, and they spend 23 hours of the day parked. And it will make a lot of sense that while parked, their batteries could those batteries and those cars could provide the energy to the services. So these are the big
Mm.
challenges for networks in the next coming 10 years.
That's a very good point you mentioned about the vehicle to grid as well, Miguel, in particular, because that's a really sort of good thing. Oh, I think we've lost Miguel mid-flight on the actual broadcast. So whilst I wait for him to reconnect, it's interesting because Miguel was talking a little bit about what's been done in Portugal. I think Portugal and Spain predominantly are hydro markets. So it's interesting to sort of know what they're doing on the other parts of the energy transition side as well. So I think let me
We
see
have
if Miguel's going to. There we go. Yes, we're back. I was going to say I
sorry,
was just talking about something.
it was a mechanical, technical problem here.
Yeah,
We didn't.
the wonders of modern technology, as we say. Yeah, I think that's
Yes, I
always the
don't
case.
know.
No, I was going to ask you because you talked about hydro, and I think that's very important. I think what looking at the pathways to a decarbonised economy in particular, what role will hydrogen play? Because we heard this talked about a lot in the opening two panels, especially the last panel about what
Mhm.
Norway and the Middle East is doing with hydrogen. But what's sort of your take on the role of hydrogen going forward?
Well, it's a marvelous world of hydrogen for the future, definitely, without any doubt. But just 1 second for regarding the previous question. I don't know where exactly I ended up before the connection went down.
I
I was talking
think
about,
you.
did I reach the V2G, the vehicles
Yes, you're
generation?
talking about V2G, exactly. Yeah.
Okay. Okay, perfect. Well, firstly, in terms of hydrogen, it should be clarified that while there are no efficient carbon capture retention technologies, we should only look at hydrogen produced through renewable energies, right? Because otherwise
Mm,
it won't be the green energy, the green hydrogen will be the blue hydrogen. So there we're not covering the energy transition. Therefore, hydrogen should and will play a complementary role to electricity, in my point of view. Although
mm,
uh, the future of mobility, and I mean cars, will definitely be electric, on my point of view, as it is more efficient and significantly cheaper than other alternatives compared to the batteries that we currently know of.
mm,
Electricity will not manage to reach all segments, namely the large air, sea, and road transport. So hydrogen presents itself as the best alternative to decarbonize these so-called heavy transport segments, but also heavy industry as well, which needs high temperatures that electricity cannot manage and then provide. So the use of hydrogen to these heavy industries presents itself as the best alternative for decarbonization. In terms of roles, well, we can pick up four big roles of hydrogen. On a system dominated by renewables, it will be important for the seasonal storage of energy, an
mm,
area which falls beyond the capabilities of batteries. For instance, today, nowadays, the gas turbines are starting to be adapted to enable to burn hydrogen or blends of hydrogen to produce electricity from stored hydrogen when required. Secondly,
mm,
definitely it will be important for mobility, especially for
mm,
long haul transport. Uh, Nevertheless, Toyota and Mirai are also betting on the use of hydrogen for cars. But
mm,
it will definitely and eventually be the solution for sea transport one day. Thirdly, but a very relevant aspect is from, I would say, feedstock for several industries, which by order of relevance we can name for ammonia, for steel, for cement industries, heavy industries. It will also eventually may play a role with synthetic fuels for
mm,
specific fuels such as aviation and transport. And fourth, but not last, it is a bit long. It's a bit a long shot, the hydrogen in the future, but it may also be used for transporting stored energy from countries with a large renewable resources to countries with a low renewable sources.
Mm.
eventually playing the role of a carrier, which may be liquefied and, for instance, transforming hydrogen to ammonia, which is much more secure, transported in big ships to other countries, for instance, from Africa or from Middle East to Europe in ammonia,
Mm.
and then transform back ammonia to hydrogen and use it in electricity. As well, hydrogen will be very important in the wind parks and the solar parks,
Yeah.
so that they can transform and store the energy in the form of hydrogen and use it with eventually gas turbines for pumping electricity in the electric systems when there's no wind eventually, or when there's no sun. But it
It's
is a
interesting
very
you say. Yeah, no,
Hmm.
it's interesting you say that because, what you said about hydrogen being now, people, you're right on the type of hydrogen because you've got what, blue, turquoise, grey. I mean, you've got a whole host of colours, but obviously when you go down
Yes,
certain paths, it's not the most environmentally friendly. So I think you've got to
no,
choose the right one. I,
definitely,
I do think personally there's going to be a collaboration on hydrogen. There's going to be a little bit of everything to make it
for sure.
sustainable. I don't think we can
Yeah.
rely on green only, for example.
Mhm.
Um, in terms of renewables, obviously we talked on the opening panel about smart grids. We had some really
Yeah.
good people there talking about what the smart grids need to do to make them more efficient. How do we adopt diverse business models to include all of the renewable energies? Because obviously you've got a few of them. You mentioned wind, you mentioned solar as well. What does the future hold for smart grids?
Well, smart grids will definitely be a critical enabler in the energy transition. Increasingly, we are
Mm,
going to see in the very near future, we're going to see the two-way energy flows where an electricity customer and customer could be at certain times of the day also a supplier, but requiring obviously grid operators to introduce intelligence in their grids so that they
mm,
transform from grids to smart grids, and that's critical. It is something that we're already seeing, but that will be increasingly important. Will be definitely an increasing important trend. In terms of market design, it seems clear today for all agents that the current model is outdated. The UE itself
mm,
has already recognized that issue and is seriously considered developing new mechanisms that will allow the market to continue to exist with these new future requirements, the flow in and flow out, and having the customers to play an important role in the energy transition of the smart grids. So I believe that the solution involves contracting on time between producers and customers, and the
mm,
introduction of power guarantees to ensure the security of supply simultaneously with large-scale storage solutions. One of the keys of success for energy systems with a lot of renewables and storage is to be able to accommodate a growing number of interactions among all types of energy resources and devices. Transactive energy system techniques are critical, well suited and needed for addressing these type of problems. A huge technological development is needed for the future systems to be materialized. Information and communication technologies are critical enablers for these developments. In the future, grids will face a development era similar to what we have witnessed with the internet.
mm.
Plug and play devices, peer-to-peer operators, and control automated systems will be mandatory. Artificial intelligence will play a critical role here,
Mm.
and, and it's a very interesting world.
I think you draw me on to a very good point because I wanted to ask you one last question on that because um, we had Kaluza earlier, we had AWS, a lot of tech companies now heavily involved in utilities and how they can
Yeah.
make them more efficient. Now, technology and innovation, I would assume, would be a very big enabler. How, though, will technology enable renewable penetration in the near future? And if so, how? How will it do that? What type of structure will that adopt?
Well, even though I'm not in deep in the area of innovation and technology and IT. My sense of view, and as you know, climate change is perhaps the biggest challenge of humanity in this century. The
Yeah.
only way to guarantee the future of humanity in this planet is to decarbonize economies. This energy
Mm,
transition presents us with great challenges, but of course, we know that we will only manage it successfully, achieving it through renewables and storage. Nonetheless,
mm,
presently, we still don't have the viable solutions for all uses. And here, innovation and technology will play a key role in the future of energy transition.
mm.
I'm sure you
Fantastic
have
points. Yeah.
insights on
No,
the innovation
no,
that,
no, I agree, but I think it's really good to have your point of view on this, because what makes an event really good is you get different points of view from different people in different
yeah,
roles, and I think that makes for a good discussion, because I think you mentioned it earlier in your answer that you can only do this if we all sort of have the same viewpoint and we all collaborate. We all sort of talk about what needs to be done. But no, fantastic points, Miguel. It's been an honor having you. I really am happy that we've had this conversation, and your tech lasted out. I was hoping it wouldn't cut out again. So thank God for that. But thank you very much for joining me, Miguel.
thank
And
you too,
we
Adam.
speak
It
again
was a
very
great
soon.
pleasure. It was a
I
great
think it's
pleasure.
an honor to have
See
you. Thanks,
you.
Miguel. Thank
Bye
you. Take
bye.
care.